hope you are fine. Welcome to the lesson in mathematics. I'm going to take you through exponential as well as logarithmic equations. Now, first of all, before we proceed, you are supposed to understand what are exponential functions and what do they do in real life situations. When we talk of exponential functions, these are relations which are basically used in modeling processes. For example, one is able to understand the trends such as population growth, earthquakes, and others. So having done that, as we have said, functions are relations, then we are going to take you through the indices. We cannot run away from indices as we are going to look at exponential equations, so we need to introduce some of the rules of indices that you learned in Form 2. Since this one is a topic in Form 3, then you need to understand the laws of indices or the rules of indices. Now we are going to study the functions such as 5 to the power x, where x is the index, or it is also called the exponent, and 5 is taken as the base in this particular case, where we have 5 to the power x. But then x is taken to be the index or the exponent, and the 5 there is the base. Now let us look at some of the rules, or sometimes we take them as the laws of indices. So these laws of indices will help us to simplify the exponential equations that we are going to solve. The first rule says that when we are multiplying indices of the same base, then we are adding the powers. And indeed here we have seen that a to the power m multiplied by a to the power n equal a m plus n. So this one basically shows that a is the base and m is the exponent, or sometimes we call it the power. Now when we're multiplying indices of the same base, here the base is a. We have the same base here. If we had b here, then we cannot add this because the powers, because we have different bases in that scenario. So now in general terms, again, number 2, when we are actually dividing indices of the same base again, what happens here is that we subtract the powers, as we have done here to demonstrate what I'm actually explaining. And this is what you really learned in Form 2. Then we have also number 3, where we look at if we have a to the power m, then close brackets, we have n there. This means that our n is going to multiply by m there. And here indeed we have a to the power n m. Then the fourth one says, the fourth rule says that any number raised to the power 0 equal 1. Any number raised to the power 0 equal 1. And in this case we have used a as n representing any number raised to the power 0 equal 1. Now let us look at before that, let us look at the rule number 5, which is looking at negative indices. If you have a to the power m, then to remove this negative m, you have to take the reciprocal, which is 1 over a to the power m. That was what is supposed to be done. Then let us look at the example and how we apply these laws of indices that we have mentioned there. So we have a problem like, for example, 1. Evaluate the following, leaving your answer in index form. 1, we have 4 to the power 8 multiplied by 4 to the power 2. Now we are going to apply the first law there, because we are multiplying indices of the same base. Then we are going to add the powers. We are going to take one base, which will be 4 power 8 plus 2, which indeed becomes 4 to the power 10. So you can see that indeed when we are multiplying indices of the same base, in this case the base is 4. So if the base is 4, then automatically we're going to add the powers, which we have added 8, and 2 are the powers, and we have added here. So we have 8 plus 2, which is going to give us 10 to the power 4 to the power 10, meaning that 4 is going to be repeated 10 times when we simplify that one. Again, here in simple terms, we have the division. We are dividing indices of the same base, and this one is just the same as 10 to the power 5 over 10 power 2 is just the same as we take 110 and then subtract the powers, which will be 5 minus 2. Indeed, we have 10 to the power 3, meaning the 10 is repeated 3 times. To simplify this, we can say equals 10 times 10 times 10, 3 times. And indeed, we may get 1000. Rule number 3, where we have 8 to the power 3, close brackets to the power 4. This one simply means 8. Remember that we multiply 3 by 4, which gives us 8 to the power 12. So this gives us 8 to the power 12. So these are some of the basic laws. Maybe we may have also number 4 to say maybe 100 to power 0. That one gives us what? 1. As long as the base is not 0, if a number has been raised to the power 0 here, everything is yielded to 1. So we get 1 there. So again, then we may proceed with another row. We saw that maybe we may have an example like maybe 4 to the power minus 2. Then if we say simplify, maybe simplify that one, then this one we have to take the reciprocal of that one, which is 1 over 4 power 2. So we are removing this negative by taking reciprocal. So reciprocal means 1 over something, so which means 1 over 4 to the power 2. It means we have removed the negative there. So therefore, we may further simplify, which may become 1 over, then 4 times 4, which goes to 1 over 16. So that one is also a simple rule that we basically have. So these are some of the laws of logarithms that we have discussed so far. But now our main aim, we have been just reminding you these laws of indices because you learned them in Form 2, and that one provides a basic foundation which we'll be applying when we are solving these these exponential function equations as well as functions. Now let us look at some of these examples of exponential equations. Let us look at the exponential equations. Number 1, exponential equations are equations which involves a power which is unknown. In this case, we are finding a power which is unknown. We don't know the value of a letter or a variable which is written as a superscript. For example, we may take 2 to the power x equals 1 over 8. Now 2 to the power x equals 1 over 8. So we have to find the value of x. Now we want to find the value of x as a variable, but that one is basically an exponent, or the unknown here is x there. So we want to find what is it, what number can we put here so that it is equivalent to 1/8. So now what we do is we still apply the laws of indices, and we see that 8 can be written in, we can say 2 to the power x equals 8 to the power -1. Now, this reminds us to say if we remove the negative, take the reciprocal of this, it becomes 1/8 to power 1 here. But now 1 is, we can just neglect it, doesn't matter there. So now let us express 8 in index form, where we know that now 8 can be written as 2 times 2 times 2. And indeed we have how many 2's? 3 of them. So which means 2 is repeated how many times? 3 times. So that one gives us 2 to the power 3, which means 8 here is also can be written as 8 to the power, alright, we can write this one as 2 to the power x equals, now we have 2 to the power what? 3, but now we have a minus there. So we multiply it by -1. Now the equation we have 2x equals 2, then we have 3 times -1 minus 3. Now the fact that the bases are the same, we have 2 here, we have 2 there, it implies that these powers are also the same. So you just equate the powers there. So therefore it means that x equals -3. So it means in this case we have solved the exponential equation. So let us also look at another example similar to that. We may have example 2. Now where we have solved for x. So for x in the following exponential. So the following exponential function. First one could be 3 power x equals maybe 42. Then in number 2 we have 2 to the power 2x plus 1 equals 128. Now all these are said to be exponential equations. Now these being exponential equations, it means we have to solve them applying laws of indices. Now we try to raise 42 in index form, where we may write 42 maybe, then we start dividing by 3, then there 1, there into 12 we have 4, then we may have save 2. Okay, maybe we may say 2 there, we have 2, 21, then we have 3 there, 7, then we may have 7, 1. Now in this case, since 42 cannot be expressed in index form, then basically what we have seen here, we have a number which cannot be expressed in index form. So automatically there we are supposed to to actually come up with a logarithm. So it means we are going to introduce the log on both sides of the equation. But now this one, since we have not learned the concept of logs, then automatically we must remember bit leave that one out, so that we concentrate on the second example where we are applying the laws of indices. Now, if you look at 128, we can express that one in base 2, which is this base here. So we have 128 divided by 2. If we divide there, we have 64, 2 there, 3, 32, 2 there, we have 16, 2 there, we have 8, then 2 there, 4, then 2 there, 2, 2 there, 1. Now, how many 2's do we have? We have 1, 2, 3, 4, 5, 6, 7. Meaning 28 here can be rewritten as 7 to the power, 2 to the power 7, which equals 2 to the power 2x plus 1. Now, we see that these bases are the same. We have 2 there, we have 2 there. And then just equate the powers here. It means now to say 2x plus 1 equals 7. Then solve this simple linear equation where we're going to have 2x equals 7 minus 1. We have 2x equals 6. Now divide both sides by 2 here. So we have x equals 3. So which means we have solved this particular exponential functions. Now, that's what we normally do. But this one you may introduce the logarithm. Now, because you haven't learned the logarithms so far, I'm afraid that you may not clearly understand what we mean. But if you find that you cannot express, this number cannot be expressed as the base, which is here, for example, 3 there. So it's advisable that you introduce log both sides so that you can solve the equation. For example, you may do this. If you find that this number, for the 2, for example, we have 3 to the power x, which equals 42 there. For example, this 42 we have seen that cannot be expressed as a base of 3. So therefore, what we're going to do is to simply maybe try to work it out, introducing both sides the logs, where we may say log of 3x equals log of 42. And then this will come here based to the laws of logarithms. Then log of 3 equals log of 42. Then divide by log of 3, divide by log of 3. Then this one, x equals log of 42 over log of 3. So you can see that from this example, this number has not been expressed in index form. So in that case, you are always forced to use logarithms. You may also have maybe 2 to the power x equals 7. So 7 cannot be expressed in index form. So what you do is you introduce log both sides. That's what normally happens. Anyway, but that's the story. Now, let us also look at the final example. Solve for x. So we may have this again, where we have this exponential function. So here is a matter of cross multiplication of 1 over 4 to the power negative x equals 1 over 2, which implies to say, we'll say 2 times 1 equals 4 to the power minus x times 1. So in this case, we are going to have 2 equals 4 to the power minus x. Now 1 times 4 to base 4 to index x minus x equals 4 index x minus x equal to. So now we have we know that here we have 1. This number has a power of 1, so we have 2 to the power 1 equals x plus 4 in index form, which is 2 to the power 2 times negative x. Automatically there we are going to have 2 negative 2x is equal to 2 to the power 1. Now if we have this scenario, it means the bases are the same. Then we have also to equate this. So we have minus 2x equals 1, and then divide both sides by minus 2. We have x equals, which is now giving us negative 1 over 2. So the answer there is negative half. So if you can see, we are solving this equation here, which starts from here, and we have 1 over 4 to the power negative x equals 1. Then here we have that copied, and what has happened here is that we have cross multiplied 2 times 1, and 4 to the power negative x has multiplied this 1, and that's what has happened here. And from there, 2 times 1, we have obtained 2, but we know that 2 is having a power of 1 there. Now 4 to the power negative x plus 4 in index form, which has become 2 to the power 2, but this 2, which is an index, will multiply by negative x here. So we obtain now 2 to the power negative 2x equals 2 to the power 1. Now because the bases are the same, then equate the powers, which is negative 2x equals 1, divide both sides by negative 2, then we obtain negative half as the value of x here. So this one becomes the value of x. For today, let us stop there. So we'll also, next time we're going to look at equations that will lead us, which are reducible to quadratic equations. Thank you very much for being good audience. Thank you. Before you go, just carry home this exercise. Maybe you may try these problems. Number 1, we may have 4 power x plus 1 2. So solve these two. I will only give you 2 problems. Yeah, so you go and solve out these problems. Solve for x in equations maybe below. So here are the equations. Yeah, so please, you are going to solve these equations, and for feedback we will see how far you have done, and thereafter we may revise if possible. After revision, then we'll go to the next topic, which is solving uh, solving exponential functions, which will lead us to quadratic equations. Thank you.